You heard about matter in the 8th grade. You may even have heard about it before then. Matter is something that's very important in chemistry. What is matter? Well, it turns out there are lots of different definitions of matter. Different books have different definitions, and some definitions of matter we don't need to get from a book. We can sort of think them up ourselves. But here's one we see a lot. Matter is anything that has mass and takes up space. A lot of books define matter that way. There's another definition. Matter is anything that has mass and volume. And really the red definition there is just a slightly different way of writing, slightly different words used than the first definition. So those definitions are pretty much the same. What about this definition? Matter is anything that's made of atoms. And that one turns out to work pretty well. There might be some situations in chemistry where we want to think of something as matter that is not actually made up of atoms. But usually, if we find something that is made of atoms, we can be sure that it is matter. And so this definition works for us pretty well. Here's another one. Matter is stuff. Doesn't sound very technical, does it? But it is a pretty good definition of matter. That's what matter is. It's stuff. My stuff is matter. Your stuff is matter. So anything that you can describe as stuff or anything that you can pick up and say, hey, here's my stuff, that's matter. How about a few examples? Here's a little pile of nice shiny rocks that somebody made. He carefully piled them up there, and are those rocks matter? Well, sure they are. If we put those rocks on a balance, we could find out what their mass was. If we drop them in water, the water would have to move out of the way in order to make some space for the rocks. So clearly those rocks have mass. They do take up space. And so they are an example of matter, of course. What about this car? Somebody's going to get a real nice present there, a nice bow around that nice red car. And that's matter. If we had a scale that was big enough, we could drive the car onto the scale. We could weigh the scale. We'd see that it has some mass. We know that a car takes up space. I mean, think about what happens when two cars try to occupy the same space. The consequences are not good. And so clearly that car takes up space, and this car is matter, and the ribbon around it is matter, and all the parts of the car are matter. Pretty easy to see. This one's a little more difficult. Think about that balloon. The balloon itself is matter. If we put it on a balance that was sensitive enough, we could get a mass for the balloon. And the balloon itself takes up space. If we had a package of balloons, we could stuff a few in the package, and there'd be a limit to how many we could get in there because each balloon takes up some space. So the balloon itself is matter. But what about the air inside the balloon? Pretty clearly that takes up space. The air takes up space because the balloon is bigger when it has the air from our lungs in it than when it doesn't have the air from our lungs in it. But does that air weigh anything? And that's a little harder to see. If we took an empty balloon, one that wasn't tied up and hadn't been blown up, and put it on a balance, we could weigh it. And then if we took a balloon, or that same balloon that was filled with air and tied up, and put that on the balance, it would be very, very hard for us to see that the air inside the balloon has mass. So think about this. Suppose we had a balloon like the blue one in the picture, and we also had another balloon, looked just like it, that we got from the store. The balloon in the picture, we could say, was filled up with air from our lungs, and the one that we got from the store was filled with helium from the cylinder at the store. And what would happen if we held both those balloons by the string and then let them go? And we know that the one that had helium in it would go up in the air, and the one that was filled with air from our lungs would sink. It might sink slowly, but slowly it would fall down to the floor. And so what does that tell us? That tells us that the air inside the balloon has some mass because it is attracted by the gravity of the Earth, whereas the helium balloon doesn't seem to be. So the air has mass, and the air takes up space. What about the helium? The helium we know takes up space because a balloon filled with helium is bigger than a balloon that's not filled with helium. And the helium doesn't seem to have mass, at least at first glance, but if we followed that helium balloon up into the sky far enough, we'd reach a point where the balloon would stop rising because the helium in the balloon would have an attraction, would be attracted by the gravity of the Earth, and that attraction would overcome the tendency of the helium to float on the air. But we'd have to get up high enough in the sky to see that. So the helium itself is matter, just like the balloon and just like the air that fills a different balloon. So the helium is matter, even though it's kind of hard to see, kind of hard to prove in a simple way that the helium is mass. What's this? CuSO4. If we were talking to a chemist and we said those letters and those numbers, a chemist would think for a minute, and then he or she would understand what it is we were talking about. So CuSO4 is the formula for a particular substance. But what if we didn't know what that means? If we saw those letters together, could we say whether this is matter or not? Well, we'll learn some things about the periodic table as we go along. And we're going to find that all matter is made up of just the elements that are on the periodic table. And each one of those elements has a symbol that begins with a capital letter. Sometimes there's also a lowercase letter that goes along with that capital letter. So if we look carefully at this formula that's written here, CuSO4, we can see the capital letter C followed by a small letter U. That's a formula for an element, Cu. And the capital letter S is also the formula for an element, and the capital letter O is also a formula for an element. And this number 4 is telling us that there are 4 of whatever the O stands for that makes up one, that are part of one unit of this substance, CuSO4. And each one of those symbols, the Cu and the S, and each one of the 4 O's represents an atom. So we just need to know a little bit about elements in the periodic table to see that this formula is telling us that this substance is made of atoms. And so that tells us that it is matter, according to the green definition on our list there. So this stuff, copper 2 sulfate, there's the name of it right there, contains 1 atom of copper and 1 atom of sulfur, that's the S, and 4 atoms of oxygen, that's the letter O. And it is a type of matter. And in fact, here's a picture of a little pile of this stuff sitting on a dish. And this stuff, copper 2 sulfate, is something that's pretty interesting for people who are in a first-year chemistry course. It has a nice color, and if we dissolve it in water, it makes a nice blue solution, and it will react with some other things. So we'll be using some copper 2 sulfate to see if we can learn some things about chemistry as we go along. And copper 2 sulfate is a type of matter. What about water? Is that matter? Well, on the left we have an empty glass, nothing in it but air, and we know that if we were to pour water into that glass, it would fill the glass up, or we could pour as much water into it as we wanted to. We could make it half filled, or a quarter filled, or 2/3 filled, just like the glass on the right, which is about 3/4 filled. And we could, so we can easily see that that water takes up space. There's part of our definition of matter. And we can also see, or we can also know, we can't really see that in the picture, but we know that if we have an empty glass and pick it up and then put it down again and fill it with water and then pick it up again, that it's significantly heavier when it has the water in it. So that tells us that the water has mass. Not too surprising to find out that water is a type of matter. So we've seen some examples of solids, the car and the rocks and the CuSO4 that are matter. And we've talked about the balloon that was filled with air or helium. And we came to the conclusion that those things, those gases, were matter. And we also talked about how the water in this picture is matter. And so that leads us to another way that some people define matter. They say that matter is solids, liquids, or gases. And that's another definition for matter that works pretty well for most of our purposes in chemistry class. So why do we care what matter is? Well, we care what matter is because of what chemistry is. Chemistry is the study of matter and its changes. So we might study that rock in the picture. We might find out what it's made of, but we also might be interested in how it changes if it gets cold or hot, or if it comes in contact with some sort of chemical that might change it. So the study of matter, the idea of matter, is really central to the study of chemistry.